All right, let's open up. Even me. Where did we leave off? So I fixed some things after yesterday's fiasco. We're on using member functions. Does this automatically open? It does. Lovely. And we can live compile. Live coding. Dum da dum dum. Oh, build failed. Why did my build fail? The paging file is too small for this operation, please. Okay, do I need a terminal build file? Java? Why is Java activating? Let's get some copyright-free music going. Paging file is too small for this operation to complete. Okay. Might need to close down Firefox. Let's try that. This was working yesterday, so all right. So that was it. Can't use Firefox. Gotta be Edge. Microsoft Edge. How you feeling?
Direction of a particular vector. Let's dive.
Using member functions.
Hello and welcome. In this lecture, we're going to be introducing member functions and this get safe normal function that will allow us to get hold of the direction of a particular vector. Let's dive in and see how this works. So our simple method for sending the platform back in the opposite direction is working at the speeds we've tested it out at. But what happens if I say, hey, let's make this platform go 10 times faster? Let's go ahead and play and see what happens. Well, suddenly that platform's jumped forward quite a lot and it's not hovering around the same location as it was before. And the reason for this is because the current location, when we set it as the start location, isn't necessarily exactly the distance moved. We could have overshot, and that is captured here in the if statement. We're saying that the distance moved is greater than the move distance, which means that we will have overshot. We have to have overshot in order to have triggered this if statement, but the question is by how much, and that's going to depend very much on how large the delta time is. We can overshoot by quite large amounts, especially if the platform velocity is large, which means that our start location may drift over time. It may not stay constant. So the better way to do this would be to calculate how far we need to move from the original start location to get to the new one using the exact move distance. So let's try and visualize this back and forth calculation. We're saying we've got a platform at its start location over here. We say it's got a velocity, which we can represent with an arrow that is a direction and a size. And it's also got a distance that we want it to move, which is represented by this brace here. Now, what we're saying is we would like to figure out the exact point where the platform would be at the end, not overshot, but just exactly the end location. Now, the way we can do this is by taking the direction of that velocity arrow. So in vector parlance, this is called the normal of the arrow, and it basically takes it down to being of size 1. So we get the direction, but a size of 1. So that allows us to know, discount essentially the size of the velocity, how fast we're going. And then what we can do is we can multiply that direction by the quantity of our distance to give us an arrow that gives us the whole movement from the start location right to the end location exactly. So let's have a look at how we can do this in C++. What we're looking for is a new start location. So let's remove how we're currently doing this, and we're going to have a start location equal to. Well, what is it going to be equal to? Well, it's going to be equal to, first of all, the start location plus something, because we're starting from here and we're adding this green vector to get to the end. So what's that green vector there? Well, that's where we need to get the normal of the platform velocity, and just to make it easier for us to understand, I'm going to split that into its own variable. So we're going to create a new variable of type fvector, which I am going to call the move direction, just to make it super clear what it is that we're trying to store in it. And then we're going to get this from the platform velocity dot get safe normal, and then some parentheses around the end. So what's going on here? We haven't seen this before. We've used dot to get hold of the components of a vector, the x, y, and z. Those were variables. But in C++ and in object-oriented programming in general, we also have functions that exist on classes. So we can use the dot operator to get hold of one of those. We've used the colon when we've been trying to get it out of the class itself. But when we want to do an operation with the actual vector itself, so platform velocities vector, we can use the dot operator to get the normal of that vector. So that's what we're doing here using a member function instead of a member variable. So we've got the safe normal of that platform velocity, and we'll put semicolon at the end of the line because here we've got a variable that's essentially, we're saying that's the move direction. So now we can use that in the subsequent line to do a move direction multiplied by the move distance that's configured, because we want to move exactly to the end, not overshoot. And then after we've done that, we should actually move our platform to the end location. So we're going to do a set actor location to be the start location, because otherwise our platform will have overshot and gone past that end location because we'll have updated it with the current location, which is the overshot location. So that allows us to move exactly to the endpoint and then start from that new starting location. Now it's important that we update the platform velocity after we do all of this, because we're using it to get hold of the move direction. So I'm going to update the platform velocity after we set the actor location. Now let's go back into Unreal and hit compile and see if this has fixed the problem with our platform moving.
Can I live code it? Does it work? Does it compile? Yes, it does.
The platform velocity after we set the actor location. Now let's go back into Unreal and hit compile and see if this has fixed the problem with our platform moving backwards and forwards. Let's close down this terminal and hit play. And now if we have a look, the platform's moving quickly, but it is moving reliably around the start and end location we would expect. So that's all I wanted to cover in this lecture. We just corrected a little bit of a bug that could have cropped up for some of our platform configurations. I'll see you in the next one. Hello and welcome. In this lecture, we are going to be making moving platforms that look a little bit more visually appealing like this by using blueprint child classes of a C++ class. Let's dive in and see how it works. So enough with this white cube. Let's start using some of the assets from our asset pack. Now, with these moving platforms, we don't want to be reconfiguring them every single time that we create them. So this is where blueprint classes come in handy. We can put a lot of the configuration into our blueprints. So what I'm going to do is I'm actually going to delete out of the scene our current moving platform, because I want to show you how we can create a new blueprint base class for these. So we've done this very similar process with the BP third person character that we're using. This is a blueprint class based off of another class. Now we can do this based off of our C++ classes. So we go to our content drawer, and there's a few ways of doing this, but this is one of them. We can go to the C++ classes, go to Obstacle Assault, and right click on the moving platform class that we've got in here and go create blueprint class based on moving platform. Let's go ahead and do that. I'm going to call it BP underscore moving platform and put it in the root of content and hit create blueprint class. And then it's going to pop open the blueprint editor that we are now familiar with. So I'm going to close my content browser. And here you can see that we've got the details pane with all of the settings that we have for our moving platform, and including the move distance, etc. We've also, it's added in a default scene root component because we didn't have a component within here. So an actor needs to have some sort of component, otherwise it's not got a location, which that's why we had to add our cube component in the previous instance. So what I'm wanting to do here is actually bring in some of the assets from our learning kit. So if we go to our content drawer, to the content folder, we'll go to the learning kit and then have a look at assets, and let's have a look at
Whoa, 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 whoa. How do I get the content drawer up again? Control space. There we go. Content drawer. Learning kit games. Assets. Whoa.
props. Well, there's lots of things, lots of folders in here. So what I'm actually going to do is filter, go to the filter button and look for the static mesh filter. And that's going to show us all of the static meshes down.
Better, where's the... static mesh.
Down under the learning kit. And in my case, I want to make a kind of stone pillar. So there's a few ways I could go about this, but I think this kit floor is one possible avenue to explore. And the other way to have a look at this, of course, is we've got the assets in our scene. So let's go and fly over to this other platform here. Go over to the floating island, and we can have a look at what assets are available. I can see that there's a stone floor that I'm liking the look of. If I click on that and have a look at the static mesh in use, you can see it's this static mesh kit floor mesh. Okay, so that's what I'm looking for in the content drawer, and I could remove the filter if I wanted to do it that way, and I could look for the kit underscore floor, I think it was. And that's the one that we want. There's two versions, actually. So let's have a little look at the differences between them. It looks like the second one is a bit more fleshed out. There's certainly more properties when I'm hovering over it. In fact, there's even some levels of detail. There's 4 levels of detail where there's only 1 for the other. So I'm going to go for the second one.
Okay, what the... Oh my, I almost clicked exactly on it. SM kit floor 40.
And I'm going to drag it into the viewport. And you can see it gets added in as a component. Component underneath this default scene root component, which is just fine. We don't have to make this kit the absolute center of the whole class. It doesn't have to be the root component. We can attach it to the root, and that actually allows us to move the center of the platform so that the center is in the actual middle of the platform rather than being at wherever the center is for this particular static mesh. So that's what I've done. I've moved my platform over to be a little bit off center. I'm also going to make this into a platform that goes up and down. So selecting the actor in the components panel or clicking on class defaults in the toolbar, I'm going to go and change some of the properties in the moving platform section. So our platform velocity, I'm going to make it go up and down. So I'm going to give it 200 velocity going up, 0 going across.
Rudder. You dragged it in.
There's even some levels of detail. There's 4 levels of detail where there's only 1 for the other. So I'm going to go for the second one, and I'm going to drag it into the viewport. And you can see it gets added in as a component underneath this default scene root component, which is just fine. We don't have to make this kit the absolute center of the whole class. It doesn't have to be the root component. We can attach it to the root. And that actually allows us to move the center of the platform so that the center is in the actual middle of the platform rather than being at wherever the center is for this particular static mesh. So that's what I've done. I've moved my platform over to be a little bit off center. I'm also going to make this into a platform that goes up and down. So selecting the actor in the components panel or clicking on class defaults in the toolbar, I'm going to go and change some of the properties in the moving platform section. So our platform velocity, I'm going to make it go up and down.
All right, I don't have that. My moving platform. Details. Application rendering actor.
So I'm going to give it 200 velocity going up, 0 going across, and I'm going to give it a move distance of 500 to start off with, and let's see how that looks. I'm going to bring a moving platform actually into my scene. So let's go to the scene, go to the outliner search for the third person character and double click on him to bring us back to this other island. Then I'm going to go to the content drawer, go to the root of content, cancel out my search, and drag in our BP moving platform. So there we go, we've got a moving platform in here, and if I hit play, you can see that it is going indeed up and down like this. And if I put two of them in the scene, so I drag in another one.
Okay, whoa.
You'll see that they both react in the same way, and they both are linked because of that blueprint class that they both share. So let's challenge you to customize your own.
Homie, I'm not seeing what you're seeing. I got variable, yeah.
Static mesh. So that's what I've done. I've moved my platform over to be a little bit off center. I'm also going to make this into a platform that goes up and down. So selecting the actor in the components panel or clicking on class defaults in the toolbar, I'm going to go and change some of the properties in the moving platform section.
Rudder, I don't have the moving platform section. So, you know, what's up with that? What if I search for it? Oh, there we go. Don't know why. Oh, it's right here.
So our platform velocity, I'm going to make it go up and down. So I'm going to give it 200 velocity going up, 0 going across, and I'm going to give it a move distance of 500 to start off with, and let's see how that looks. I'm going to bring a moving platform actually into my scene. So let's go to the scene, go to the outliner search for the third person character and double click on him to bring us back to this other island. Then I'm going to go to the content drawer, go to the root of content, cancel out my search, and drag in our BP moving platform. So there we go, we've got a moving platform in here, and if I hit play, you can see that it is going indeed up and down like this. And if I put two of them in the scene, so I drag in another one, you'll see that they both react in the same way, and they both are linked because of that blueprint class that they both share. So let's challenge you to customize your.
Just kidding, that was mean. Alright, so this is what he wanted. Lovely. We're on track.
Own platform here. You may choose to go with the approach I'm going with, or you may go entirely different. You can also create more than one blueprint variant class so that your moving platforms could be some that float, some that go side to side, some that are pillars coming out of the ground. I'm going to go for the rock pillar coming out of the ground as the idiom. So and if you want to follow along, that's your challenge as well, to make it a pillar emerging from the floor.
Make it a pillar emerging from the floor. What? Or these again. I can rotate this, I think. 90 degrees. Do this. This. No, I attach them. Eek Babaderko. Damn near perfect. How do I group them?
What we're going to have to do is look for some appropriate components from the kit that could be the sides of the pillar. Then we're going to drag them into the blueprint class and we're going to position them in place so that they form the base underneath that floor component that we've already put in. So pause the video and have a go at making your own rising pillar. Okay, welcome back. So let's stop playing with our rising pillar. I'm going to go over to the BP moving platform. In fact, I'm going to go over into the scene view first of all, and I'm going to travel over to the other island here by right-clicking on it and going snap view to object. So I snap right to that island, and then we're going to look for different walls that I could use. Okay, so there's a few rocky walls here that I'm seeing. That could be a good component. You could also put little holes in the wall if you wanted to. There's some kind of sloping roof, but that's kind of already at an angle. That might not be the ideal. There's also, we could use these upturned islands. These could be used as part of a more rocky and craggy base if we wanted to, but I'm going to go for a slightly more boring wall. So I'm just going to use the kit wall. Let's go over to the moving platform. I'm going to open up the content drawer and look for kit underscore wall. And then using, let's find which element is the most appropriate. I think it's this one here. It's got 4 levels of detail, so that's the one I want. And I'm going to drag it into the world, and I'm going to need a couple of them. But let's start off with just the one. So I'm going to position it down and across from our platform, like so. And then I'm going to duplicate it with just a Control-C, Control-V, and then I can rotate using the Rotate tool. There you go. It's made the other side automatically. Now let's go and paste it again. Use the Move tool to just flip it over to the other side here. And I'm not being too careful with positioning because I think it's rocky. It can be a little bit haphazard. Then I'm going to copy the one side that's already aligned and bring it over to the other. So in total, we have about 4 wall elements, like so. And then what we're going to do is we're going to take all 4 of them, and we're going to copy them and paste them, and we're going to drag them on down to be the elements down below as well, so that this is a nice tall rocky pillar that should allow us to pop out of the ground. And I'm just going to do one more level down so that we can use it in particularly tall situations. And then we're going to go and save, go back over to the main.
What the rudder?
Main level out 4, bring it over to the other. So in total, we have about 4 wall elements, like so. And then what we're going to do is we're going to take all 4 of them, and we're going to copy them and paste them, and we're going to drag them on down to be the elements down below.
Okay.
low as well, so that this is a nice tall rocky pillar that should allow us to pop it out of the ground. And I'm just going to do one more level down so that we can use it in particularly tall situations. And then we're going to go and save, go back over to the main level. We're going to go double click on our third person character to zoom us back and hit play. And now these two rocky pillars that I've got are popping in and out of the ground just fine. You can see they're going in sync with each other. We could work on changing that if we wanted to, but they are going up and down and both have sides to them, so I can't get trapped underneath. And it also gives them a bit of a sense of grounding rather than looking like magical floaty platforms. Great stuff. So we've learned about how we can create blueprint child classes off of C++ classes. I'll see you in the next lecture.
I'll see you in the next lecture. Don't fly, dude.
Hello and welcome. In this lecture, we're going to be setting up our own little obstacle assault course, and we're going to be implementing these little pusher platforms here that will push our character off. We're going to have to implement a few little fixes to our character class in order to do this. So let's dive in and see what they are. So another type of puzzle I'd like to include using this basic moving platform component is to have a pusher that will basically push us off of a ledge. Now, the way that I want to do this is take this cube here, I think it's called Puzzle Cube A, and that can be the cube that is essentially the pusher, and we're going to configure it slightly differently from the moving platform. So let's go ahead and navigate back to our platform. So I can right click and actually click go here, which takes my camera kind of to focus on it. And then what we can do is go to our content drawer, to the C++ classes, clear my search, go to obstacle assault, right click on the moving platform and create a new blueprint class based on it. This time I'm going to call it the...
Yo, chill. You just went so fast.
VP. So another type of puzzle I'd like to include using this basic moving platform component is to have a pusher that will basically push us off of a ledge. Now, the way that I want to do this is take this cube here, I think it's called Puzzle Cube A, and that can be the cube that is essentially the pusher, and we're going to configure it slightly differently from the moving platform. So let's go ahead and navigate back to our platform. So I can right click and actually click go here, which takes my camera kind of to focus on it. And then what we can do is go to our content drawer, to the C++ classes, clear my search, go to obstacle assault, right click on the moving platform and create a new blueprint class based on it. This time I'm going to call it the VP underscore pushing cube, like so. I'm going to put it in the root of content and click create blueprint class. Now I can close my content browser. I'm not sure why it keeps wanting to bring that one up. And I'm going to go is go to our content drawer, to the C++ classes, clear my search, go to obstacle assault, right click on the moving platform and create a new blueprint class based on it. This time I'm going to call it the VP underscore pushing cube, like so. I'm going to put it in the root of content and click create blueprint class. Now I can close my content browser. I'm not sure why it keeps wanting to bring that one up. And I'm going to go to the content drawer, go to the root of content and search for the puzzle cube, all one word. And we're looking for the Puzzle Cube A, so that's this one here, the mesh. I'm going to drag in to our blueprint class and then close the content drawer, close my compiler results so I can see the viewport a little bit better. And I actually want to scale this cube up because by default it's actually quite small. I'm going to make it at least 10 times bigger in every dimension. So I'm going to hit a little padlock and search for the Puzzle Cube, all one word. And we're looking for the Puzzle Cube A, so that's this one here, the mesh. I'm going to drag in to our blueprint class and then close the content drawer, close my compiler results so I can see the viewport a little bit better. And I actually want to scale this cube up because by default it's actually quite small. I'm going to make it at least 10 times bigger in every dimension. So I'm going to hit a little padlock next to the scale property so that each of these basically scales the same. And I'm going to change one of them to 10 and then the other two will scale up to 10 as well. And then what I'm going to do is I'm going to change the direction of movement. So it's currently moving in the X direction. And if we look in our scene, you can see that that's basically the forward direction. I want to move it side to side. Obviously, we could rotate it once we put it in the scene, and it wouldn't matter so much. But I'm going to change it to 0 in the X. And it needs to be reasonably fast for it to be an obstacle that we need to avoid. So I'm going to make it 300. And I'm going to make the move distance very large too. So I'm going to make it at least 500 to start with. And obviously this can be then configured again once we place this in the level. So let's save that, go into our level and try and place this cube. I'm going to cancel out my search in the content drawer, go to the root of content and drag in a pushing cube. It's absolutely massive. I definitely got the scale way off. So let's go back to the blueprint class for the pushing cube, go look at the scale property, and maybe we just want to make it 4 times larger. And note that I'm doing this with the scale lock on. So I'm making it 4 times larger in every dimension. And go back into the level. And this is looking a lot more reasonable now. So you can see that it's actually clipping into the ground a little bit. So what we can do is we could either solve this by lifting up the cube in the world, or we could do it once and for all and actually lift it up in the pushing cube class instead. So I think we're going to need to lift it up by about, let's start dragging up and see what looks sane.
What?
I think about 200 puts it on the ground plane. So save that, go back into our scene, and there you go. It looks like it is correct now. I'm just going to move it so that it's going to overlap with our player. Let's go ahead and hit play. And you can see it's moving backwards and forwards. It's not moving very far backwards and forwards, so I think we do need to change that. Let's go back to the class, go to the class defaults, and make the move distance. I think it's going to need to be at least 1500. like so, and we might want to set the move direction in the opposite direction, although that could just be a matter of preference. So let's go back to our main window and drag the cube over to the left instead, because that's the direction it's going to be moving in. Let's hit play, and there we go. It's going past very slowly, so I'm not happy with the speed. Let's change that speed. I think it needs to be at least 3 times faster, so let's make it 900, hit play, and there you go. We've got a bit more of a challenge. However, we've also got a bug. Our character doesn't really get pushed in a very sensible or nice way by this pushing cube. You can see it glitches, it's not smooth. However,
Whoa.
I would like to draw your attention to a little workaround. If I'm trying to move while it hits me, you notice that it actually does it all very smoothly. And that is because the character code doesn't actually check for collisions unless you are trying to move. So there's a little bit of a workaround for us to do this. We're going to go to our BP third person character that we've created. Now, the way you can get to this is either via the content drawer, or you can select the character in the scene, go to the details pane, go to the blueprint button, and hit open blueprint editor. Pushing cube, you can see it glitches, it's not smooth. However, I would like to draw your attention to a little workaround. If I'm trying to move while it hits me, you notice that it actually does it all very smoothly. And that is because the character code doesn't actually check for collisions unless you are trying to move. So there's a little bit of a workaround for us to do this. We're going to go to our BP third person character that we've created. Now, the way you can get to this is either via the content drawer, or you can select the character in the scene, go to the details pane, go to the blueprint button, and hit open blueprint editor. And what we want to do is essentially every single tick, we want to move the character a little bit to the left and then a little
Homie.
bit back to the right. Now, the way we're going to do this is using a component on the character called the character movement component. So select that in the components pane, then right-click in your blueprint event graph, and then search for move updated component. Essentially what this function does is it tells the movement component that it should use its character movement rules to move the character around. So you can see that it takes a delta, which basically says this is how far you should move, and it has a sweep, which tells us that it should look out for any collisions along the way. So we can make it do a very straightforward movement of basically 1 centimeter in the X and Y. It doesn't so much matter whether it moves in the Z because we're not looking for those collisions really. Then we can take the tick and drag the execution pin into our move updated component. And if we left it like this, it would be problematic because gradually our character would be drifting. Let me show you. If I hit play, you can see that the character is gradually 1 centimeter at a frame at a time is drifting his way across the scene. So what we need to do is also move back. So dragging our character movement component down here, I'm going to drag off of this pin again and look again for the move updated component. I'm going to thread in the execution pin so that it gets called out of the first move updated component. And then I'm going to make the move updated component. I'm going to thread. So dragging our character movement component down here, I'm going to drag off of this pin again and look again for the move updated component. I'm going to thread in the execution pin so that it gets called after the first move updated component. And then I'm going again for the move updated component. I'm going to thread in the execution pin so that it gets called after the first move updated component, and then I'm going to make the delta -1 in the X and -1 in the Y. So the end result will be that nothing seems to have happened. However, because we've forced the movement component to look for these collisions with the sweep, it's going to react smoothly to the pusher. So let's go ahead and hit play and go and stand in the path of our pusher. And you can see we very smoothly get nudged just out of the way like so. So I'd like to challenge you to make an obstacle course of your own using this pusher and moving platform components that we put together here. So here's the example of the obstacle course that I've made in my prototype. You can see I've got some moving platforms to raise me up onto a little island, so you can use one of these islands and scale it down as a platform, and then I've got the pushers moving backwards and forwards that I have to make my way through. And then there's rotating platforms, but we're going to get to that later, so don't worry. But we've got these pushers and we've got the moving platforms. So have a go. You can try and replicate this, or if you're feeling creative and want to try something different, then please go ahead and create your own obstacle course, because that's always really exciting to see. And if you do create something unique, please share it in the discussions so that we can all have a look and get inspired. So pause the video and have a go. Okay, welcome back. So now that we've got our pushers working, let's make something a bit interesting, shall we? So I'm going to take this platform and actually rotate it around so we've got a bit more length to our setup. And I'm going to drag it along so the character is right at the end of the platform.
Can I edit just this one? Oh yeah, I can.
And then I'm going to take these two moving platforms and position them one after the other. And one of them I'm going to add 1000 to its Z axis. And I'm going to send it moving in the opposite direction. So these two platforms should meet somewhere around the middle. Then I'm going to duplicate the floating island that we're standing on. So by alt-clicking and dragging, I'm going to rotate it just so it doesn't immediately look obviously the same platform. I'm going to drag it out, and I'm going to rescale it a little bit so that we can fit it on top of the other platform. Because ultimately what I want to happen is that once we get on top of this upper platform, we get pushed down, so we don't die, but it gives us a bit of a setback. Now I'm going to take these pusher cubes. I'm going to actually just drag them in onto the upper platform. I'm going to put a few of them in. So I think 3 is enough for the time being. And I'm going to drag one of them over to the other side and flip its velocity like so. So instead of being 9, it's going to be minus 900, and we're going to go in the opposite direction. Let's try this out. So I can get up onto these moving platforms. They allow me to have a bit of a ladder up here. And now I have to try and get past these guys. And interestingly, I just noticed a little bit of a bug with the way that we're forcing our character to move. And I'll cover that in just a second. But yeah, it's a little bit challenging, but it is doable. We could definitely get through those. I'm not doing it very well at the moment, but we could definitely get through those cubes if we wanted to. So the next thing to do is fix that little bug. Now, the issue here is that when we've called move updated component, we're setting a rotation in here that is not our character's rotation, which means that it's always going to put us facing forwards. So the easy way to fix this is to right-click and do get actor rotation, and simply pass the actor rotation in to the new rotation for move updated component. You can pass it in to both of them, but the one that really matters is that we'd be doing it for the last one. So we can go ahead and play now, and we should be able to see the move updated component. You can pass it in to both of them, but the one that really matters is
Look at me just being up here. I can fly. Screw your obstacle course. I have the power of flight. Mere mortal.
that we'd be doing it for the last one. So we can go ahead and play now, and we should be able to see that we can indeed now rotate our character as appropriate. Well, great stuff. In this lecture, we have fixed a little bit of a collision bug with our character, and we've set up a little bit of an obstacle assault course for us to get started. I hope you've had fun, and I'll see you in the next lecture. Hello and welcome. In this lecture, we're going to learn about the game mode class in Unreal, and we're going to see how that allows us to right-click and use the play from here menu item to start from anywhere in our level. Very useful for playtesting. Let's dive in and see how this works. So one thing we don't typically do in Unreal is actually have our character in the world when we start. We've seen in the past that often that character gets spawned in from a player start point. And the reason for this, among other things, is that it allows us to be a bit more flexible about how the player starts, so that if we were trying to play test our level and wanted to start off already on the cliff, we could right-click on the cliff and go play from here. If you try that out right now, you'll notice that actually you just end up where we've placed the character. And the reason for that is that Unreal doesn't actually know what character we want to use. Now, the way this typically gets solved is with a class called a game mode. A game mode is essentially an actor that goes into your level and controls the rules for the game. It tells it how to do things such as who should spawn where, what class we're going to use for the player, as well as many other classes that define how our game works. And in multiplayer games, it can control things like how many players are allowed in a given game. It can also control win conditions, so things like capture the flag tends to be a game mode, or battle royale, maybe a different sort of game mode.
Yeah.
These are what we mean by the rules of a particular game or a particular match. Now, if we go to the toolbar and click on the blueprint dropdown, you can see that under the project settings and under the world override, there is a menu item called game mode. So we've got a setting for the project as a whole, which tells us what is the default game mode for any level that we create within our project. And then we have the world override, which tells us this is the game mode for this particular level. So you can see that at the moment we are using something called the BP Learning Kit game mode. And that's included with the kit and the project that we created. So what we actually want to do is go and create our own. And we're going to do this in Blueprint for the time being, but it is possible to create game modes in C++, and we will do that later on in the course. So let's go to the project settings and game mode menu item, and then go over to the create submenu. And then what we're going to do is we're going to select a base to base this actor class off of. And the one I recommend you use is the game mode base. It's the one with the most minimal settings and things included, so we don't get anything we don't need. So we can click on the game mode base to create a new game mode. And we got to choose a name like we would for creating any other actor blueprint. So we're going to call it BP, always starting with that BP prefix when we're creating blueprints. And it's going to be BP underscore obstacle assault game mode. And I'm going to put that in the root of the content folder and hit save. And now it's going to open up into its own tab, and you can see that it is really just the actor tab, so exactly like any other actor. And the interesting thing is if we go to our class defaults to have a look at the properties and settings of the actor itself, you can see that there is a section called classes. And this is what dictates what player we can have spawned into the world. So this is what we want to change. We want to find particularly this section called the default pawn class. We've talked about how a pawn is essentially the player that you play with. So we're going to, instead of the default pawn, select the drop down and look for the BP third person character. That's the character that we've created. And we're going to set that as the default. Then we're going to hit save and go back to the main level. Go to the blueprint drop down, and you can still see we have this world override for this particular map. We want to clear that so that the default project game mode is the one that's going to be used. So let's select the world override and go to where it says select game mode class, and we're going to go and select none. So now in the drop down, if you have a look at it, you can see that it's saying that the game mode is not overridden and we're using the project default game mode instead. However, if you right click somewhere in the world and click play from here, it's still not going to work. And the reason for that is we still have this character in the level that wants to take over, essentially, because we've told it to, and we don't have any player starts. So I'd like to challenge you to fix that by adding a player start, remove the current character from the scene, open up the place actors panel, and drag in the player start actor, then test it out and see if when you play, you start from the player start.
Homo.
And also see if you can right click somewhere and click play from here and see if that works too. Pause the video and have a go. Okay, welcome back. So going to start off by deleting the character here. Got my place actors open. Obviously we can do that from the quickly add to project button in the toolbar and open the place actors panel that way. And we can drag in a player start into the scene. So place it in roughly where the character was. Hit play, and boom, our character is spawned in. Now, what about that right-click menu option? So I'm going to go on top of our platform, right-click, play from here, and here we are, right on top of the platform, allowing us to play test our game far more easily than if we had to go through the entire level every time. Great stuff. We've developed a bit of an understanding of the game mode class, really crucial in Unreal game development. I will see you in the next lecture.
I'll see you in the next lecture. All right, that's it for me for now. Let's rip some craft to round this out. Minecraft.